A very good evening, guys. Today we'll discuss about unsupervised machine learning technique, and in this unsupervised machine learning technique, we have a K-means. So we will focus on that K-means. So K-means is the part of the unsupervised machine learning algorithm. So we all know about the unsupervised machine learning algorithm. What is the unsupervised machine learning? In that unsupervised machine learning algorithm, there is no any kind of output column. Based on that input data, we have to group. We have to create a cluster. So here, if you consider this particular example, here we have a sepal length and sepal width, and I have a three cluster. Okay. I have a three cluster. One is the green cluster, another one is the blue cluster, another one is the red cluster. So the first step of K means is that we have to initialize a K. K means what? K means how many group we will create. If the K equal to 3 means we have to create 3 group. If the K equal to 2 means we have to create the 2 group. So here in this particular example, the K equal to 3. Why? Because we have created the three cluster or three group. Now, what is the second step? We have to initialize a centroid. We have to initialize a centroid. Centroid is nothing but a center. Here, if we consider about this particular example, the black one is the centroid. Okay, the black one is the centroid. So what we'll do? We have a next step. In that particular third step, we have to calculate a distance between a centroid and each and every data point. A centroid to each and every data point. Now, consider this particular example. Here, we have a blue cluster and the red point is the misclassified point. Okay, so we have to calculate what, guys? We have to calculate a distance. How we'll calculate the distance? Based on the Euclidean distance, we have to calculate a distance. Now, I have calculated the distance between this centroid and this particular red point. So this is the uh, very minimal distance. Okay. So previously it was what, guys? It was the red. After calculating the distance, it is very what? It is very shorter distance. So it will convert it. It will be converted to red to blue. Okay, it will be converted red to blue cluster. I hope you understood. In that way, based on the shorter distance, we have to assign a cluster. Based on the shorter distance, we have to assign a cluster. We assign a cluster. Okay, now there is the fourth step. The fourth step is like that. We have to calculate again the mean of sepal length and sepal width in our case. And after calculating mean, we have to move our centroid. We have to move our centroid. Previously, it was here. Then we can move our centroid. After moving a centroid, again we have to go for a third step. And again we have to calculate a distance. And based on that shorter distance, we have to reassign a cluster. So this process will be like a iterative process until and unless we will create the proper cluster. It will be like going on. The process will be like going on. Okay. Until and unless we will create a proper cluster, the process will be like moving on. So this is all about the k-means. Now I have told the k value is like 3, 4 like that. But how we will define a k value? How we will define a k value? So there is the uh, method, that is the elbow method. That is the elbow method. So here, if you focus about that particular graph, there is the relationship between the number of cluster and the WCSS. WCSS means within cluster sum of square. Okay, within cluster we have to calculate the distance and we have to take the summation of all those distance. So here the relationship between the number of cluster and the WCSS. Now if you see, guys, very carefully, the WCSS 1 is greater than WCSS 2. Okay, WCSS 2 greater than WCSS 3. So in that way, when the value is like 4, the value is like 4, after that there is not any kind of changes. There is not any kind of changes. Okay, so we have to choose this particular point will be our k value. We have to choose this particular point will be our what, guys? The k value. See, after that 4, there is not any kind of changes. The graph is like fixed. So we will consider this particular point will be the k point, k value. Okay. If you consider here, there is not that much difference. The k equal to 4 also, the graph is like fixed. The k equal to 5 also, the graph is like fixed. But when it has started the trend from that particular point 4. So this particular point will consider the k value, and k equal to 4 means we have to create a 4 cluster. I hope you understood. I hope you understood. And there is a concept of how I will check or how I will validate the performance of the k-means. For that, we have a silhouette score. We have what, guys? We have a silhouette score. Uh, just a minute. So I have opened the Wikipedia page. You can refer to Wikipedia page. The page is like awesome. So if you consider the silhouette score value range between -1 to +1. +1 means the validated score is very good. Towards -1 means the validating score is not good. This is very bad. I hope you understood. And what's the formula of silhouette score, guys? This is the formula of silhouette score. This is the B of I minus A of I uh, divided by max of A of I comma B of I. What is the A of I and B of I? Within cluster, you want to calculate a distance. So this is the part of A of I. What is the B of I? There is another cluster. And from this particular cluster, you want to calculate a distance between AI. Okay, so this is the BI. Within cluster, if you want to calculate the distance, this is the part of AI. Okay, there is another cluster. From that another cluster, you want to calculate a distance. So this is the BI. I hope you understood the concept. Just try to remember one thing. If the validation score is good, means this is towards +1. If the validation score is bad, means it is towards the -1. Hope you understood the concept and enjoy the topic. Bye, guys.